So we found that our friction force is equal to mu k mg times cosine of theta, and that the distance across which it has been applied is h1 plus h over sine of theta, which is also 30 degrees. So if we plug in 30 degrees for theta, we have mu k times mg times cosine of theta times cosine of 30 degrees, and this is h1 plus 1 over sine of 30 degrees. So now we say the work then is just equal to this times this. So we have mu k mg times h1 plus h, and then we have cosine over sine, which gives us cotangent of 30 degrees. So this is the work done. And we said that the work done is equal to the change in energy. And the change in energy was just the difference between the potential energy at this height and the potential energy at this height. So we said this was mg h1 minus h. Now we can cancel out the mg's on both sides to get mu k h1 plus h. Cotangent of theta 30 degrees is equal to h1 minus h. So now we want to isolate and solve for h. So what we can find is we can move h to the same side to get mu k h1 cotangent of 30 degrees plus mu k h cotangent of 30 degrees. Add h to both sides to get this equals h1. Subtract this on both sides to get, and we can combine these two. So we have h mu k cotangent of 30 degrees plus 1 is equal to h1, and we can combine those again. We have 1 minus mu k cotangent of 30 degrees. And so we find that h is going to be equal to h1, and we have a ratio of 1 minus mu k cotangent of 30 degrees over mu k cotangent of 30 degrees plus 1. So now we want to plug in our values. We have that h1 is equal to 1, and we have that mu k is equal to 0.4. And what we find is that this turns out to be 0.18 meters. And thus, we find that once our block goes up another ramp, it has lost some energy due to friction, and as a result, it goes up to a lower maximum height on the second ramp. And this height we found is 0.18 meters.